the remainder theorem says the following. If we divide f of x by x minus c, then the remainder is precisely f of c. Let's look at an example. So I could look at like f of x equal to, say, x squared plus 4x plus, I don't know, 3. And let's divide by x minus 1. So how's that work? I'll do the easy part, x. What do you get next? What remains after the first subtraction? I got a 5x, all right, I'll buy it. And 5x plus 3, right? And then how do I get a 5x from x minus 1? I multiply x minus 1 by what? By 5, so x plus 5. So I get 5x minus 5, and what happens when you get what? 8? So this is the remainder, right? What's the remainder theorem tell you? Whatever that number is, it should be the function evaluated, the polynomial function, of course, evaluated at 1, right? What is f of 1? One plus 4 plus 3, which is what? Whew, that's a relief. I would hate for the theorem not to be true for the example, right? Fortunately, this is not how math works, right? If math is correct, it should work for all examples that fit the terms and conditions of the theorem, right? So do you see the relation between like the remainder theorem and the factor theorem? What does it mean for the remainder to be 0? By the way, let me just write out what this means. What we just figured out is that if we take x squared plus 4x plus 3 and we divide it by x minus 1, what we get is x plus 5 plus 8 over x minus 1. You could actually use this formula to graph the function. All right? Now, I need to talk to the other instructors of this course to find out whether or not it's something we cover in here. But some people in pre-calculus might cover something called a slant asymptote. So, you know, if we just had y equals to like 8 over x minus 1, that's easy enough to understand. You just have a vertical asymptote at x equals to 1. All right? And by the way, guys, I'm getting ahead of the story here. This is the end of chapter. What I'm doing at the moment is like section 3.6 to 3.8. So, we'll be back. We're going to focus on polynomials and how they factor and how they graph for the next day or two. Once we get past that, then we look at how to graph what are called rational functions. But like this is a rational function, because a rational function is when we have two polynomials divided. So our ultimate goal in this chapter is to learn how to graph things like this. But what I'm trying to say is this might be too hard for this course. I have to talk to the other instructors and find out, but as you know, I'm new here. But so the graph of this, now what I'm doing right now is definitely not too hard. This is for sure something you should be able to graph. And so this looks like this. Basically, that's the y equals 8 over x minus 1 graph. What happens when you add, what does y equals to x plus 5 look like? That's a line with slope 1 with a y-intercept of 5, right? So it's basically something like this, you know? What happens when you add these two? Well, what you can do is basically think about x equals to 5, x plus 5. It's sort of a, well, let me make it, zoom in here a little bit more. And so the graph, you can essentially just kind of draw, there's like a vertical asymptote. I can't do it worth anything, but so it does some kind of funky thing like something like that. And there's a vertical asymptote for this one still at x equals to 1. And you can see that sort of thing from this kind of formula. Anyway, I will shut up for today, and I'll see you when? Tuesday. What? Oh, wait a minute. That's right. I'll see you when? Thursday. Woohoo! What's due Thursday? What's due Thursday in here? Better not be nothing? I couldn't have said it better myself. There better not be nothing due Thursday, because I haven't assigned anything.